Hello everyone, welcome to the Skill Talk. So today we will be continuing our series on thermography. So this video we will be discussing about the fundamental principles that how heat moves in material, and these principles are conduction, convection, and the radiation. I believe most of you have heard about this. So in this video we will be understanding that why it is important to know about these fundamental principles, because thermography is not just about seeing the images or seeing the colors. So before discussing about these principles in details, let's understand that why heat transfer matters in thermography. I believe that you have watched our last two videos on thermography, where we have discussed that thermography doesn't mean the temperature of an object, right? So it's generally the measure of the infrared radiation that is coming out, or you can say the emitted from that object. So overall this radiation is the result that how heat is moving within the object, or you can say the between the object and your infrared camera. So it become very important to know about these principles, otherwise there will be definitely this can lead to our wrong interpretation, or you can say the wrong diagnosis of the fault. So let's move to the first principle of the heat transfer, that is the conduction. So what is this conduction? So conduction is the flow of heat through one metal to the another metal, or you can say the from one solid to another solid. So the heat transfer because of this delta T, or you can say the difference in temperature between two metals, is known as the this process of heat transfer is known as the conduction, right? So when we apply heat to any of the solid, so its particle starts to vibrate faster, and these vibration got transferred to the another particle, or you can say this energy is got transferred to the another particle, and like this the heat transfers from one particle to another, or you can say the inside the solid, right? So it bumps into its neighbor particle and transferring its energy to the next one. So this process continues, and this is how the heat is transferred in a solid material. So there are key factors on which conduction process depends. So the first one will be the thermal conductivity of the material. So as high the thermal conductivity of material is, so more heat transfer will be there between metals. So thermal conductivity is directly proportional to the heat transfer. So if you will take the example, let's take very simple example that in metals you normally sees that the heat transfer very fast in comparison to the plastic, right? So this is one of the example of the thermal conductivity. So the next one will be the key factor will be the cross section area, or you can say the thickness, or you can say the shape of that object. So since there will be a thicker or the wider object, so definitely the heat transfer will be slow. And if there will be a thin metal plate, or you can say the thin metal is there, so definitely the heat transfer will be very fast. So the second one is the cross section area, and the third one will be the temperature gradient. What is this temperature gradient? Temperature gradient is the delta T, or you can say the temperature difference. So the bigger the temperature difference between two ends of a metal, so there will be the faster heat transfer will be there, or you can say the faster conduction process will be there. So these are the three key important factors that affects the conduction process. Let's take on some examples of this conduction process. The basic example that I can share with you here is the heat transfer in the bearing. So for example, you are going for the site visit, and you see that one fan is having a high temperature in its drive and bearing. So what you will do, you will do inspection of this bearing using your IR camera, or you can say the thermography camera. So let's say you find out that the casing temperature, the bearing housing temperature is, let's say 70 degrees Celsius, right? So it doesn't mean that the actual temperature of that bearing will be the bearing housing will be the 70 degree. Maybe the bearing which is inside that housing is having more temperature than that, maybe 80, maybe 90. So because of this, the conductivity, or you can say the thermal conductivity difference between the material of housing and the bearing, there are chances that the heat transfer will be may be less. Okay, it can be that okay, the proper heat transfer can be there, depends on the property of that metal, but there are higher chances that the heat that is radiating out of that housing is comparatively less than that of actual temperature of that bearing. Principle of heat transfer, that is known as the convection. So what is this convection? Convection is the process of heat transfer through a liquid or a gas, right? So normally there are two types of convections. One is the natural convection, another one is the forced one. So what is this natural convection? Natural convection, we can say, let's take a very basic example. Suppose that one equipment is running outside, and that bearing is having a very high temperature, or you can say the temperature of 70 degrees Celsius. So in the surrounding there will be cold air is flowing from one place to another. So definitely this cold air will touch to this bearing housing temperature and flow out some of the heat from them, right? Or you can say it will reduce the temperature of that bearing. So this is the example of the natural convection. And then the another one is the forced convection. What is this forced convection? So forced convection, you can say that we are trying to reduce or you can say the flow the heat from one part, or either can be mechanical or the electrical part, to the surrounding. So let's say let's take an example of electrical motor. So in electrical motor, you have seen that at the back end there is a cooling fan. Okay, so this cooling fan is generating air, and this air is transferring through the fins of that electrical motor and making that electrical motor cool. So this is the example of the forced convection. So I believe we have discussed both the examples. One is related to the cooling fan of a motor, and another one is the if we are carrying out any outdoor inspection. So definitely we have to consider the wind, or you can say the air, as a factor. So the heat that is transported away by this convection process can always create a false pattern, and maybe we can misdiagnose the fault. So let's move to the the third principle, that is the radiation. So what is this radiation? So radiation is a transfer of electromagnetic waves, or you can say the heat, and all the objects that are above absolute zero, they emit the IR rays, or you can say the infrared radiation. So what this absolute zero means, it's all the objects that are having the temperature more than 0 Kelvin. Let's discuss the factors that are affecting the radiation of a material. So first one will be the surface emissivity, right? So if the material is having more surface emissivity, so that will reflect more IR energy. Second one will be the reflected radiation. So if there is any material that is having a shiny surface, so it may reflect heat from another source, and this can mislead the high temperature, or you can say the hotspot in our thermal image that we have captured using our IR camera. And the third one will be the atmospheric effect. What is this atmospheric effect? It's maybe the atmosphere is it's dusty today, or maybe there are moisture in the atmosphere. So these like moisture, dust, and all these gases, what happen that they can absorb the IR radiation that are coming out from an object. So this also can mislead the thermal images that we have taken of that object. So it's very important to consider the atmospheric effect, right? If I will take one example, let's say that one stainless steel pipe is there, and that is carrying out a high temperature fluid. That temperature is more than 100 degrees Celsius. So this pipe may look cool in our thermal image because this stainless steel is having the low emissivity, right? So it's very important to have all the correct details of an object before performing thermography of that, right? Let's take one common example so that we can understand all three principles with one single example. Okay, let's say there is a hot electrical contact. So this hot electrical contact will conduct the heat into the surrounding component. Okay, let's say there is a loose connection. So this loose connection will this will transfer the heat using the conduction process to the nearby wire, right? Then what happened that let's say that air, the normal surrounding air is flowing through, and what will happen that this air will take away this heat from this panel. So this heat, the takeaway heat, is process of convection. And the last one is the infrared radiation, or you can say the infrared energy that our thermal camera is capturing. Okay, so that is the actual surface radiation of that panel. Okay, so this is known as the radiation. So this is the perfect example of all three process. One is the conduction, one, and then it's convention, and then how we are capturing the radiation using our thermography camera. So as a role of a thermographer, it's very important that we should have a proper thermal image by eliminating all these effects. So it's very important to have an understanding of all three principles of this heat transfer, that is the conduction, convection and the radiation. Otherwise we may lead into a wrong thermography image of an object, and definitely it will lead to the wrong analysis. So it's very important to master them. That's all for today's video on basic principles of thermography. And please don't forget to like, subscribe and share this video if you found this helpful. And this is the Skill Talk, turning skills into power. Thank you for watching. We'll meet you in the next video.